This is Chapter 18, Example 1. This circuit we need to design here has designing a circuit that outputs one of two values. So it outputs one value. And inputs are two 8-bit inputs, trying to establish the high-level black box diagram here. The big thing here that we need to be aware of, we have to make sure the output's always valid. It's assigning it's adding one of two 8-bit values, so technically speaking, the output could be 9 bits. That was our first concern, is making sure the output is wide enough, and it needs to be 9 bits to handle this addition. And that is my top level black box diagram. Next step in the solution is to look through, kind of take an inventory of the modules that our circuit will need. And so what do we see here? We see it's either adding a plus b or doing some type of multiplication. By the way, the multiplication we don't know how to do, but we're going to accomplish this by essentially adding a value to itself twice. That's going to give us the 2a. So we need a ripple carry adder in this thing. Use no more than one RCA in your design. Okay, there's the one RCA. Assume inputs. So the other part of this problem here is going to add one of two things. It's either going to add, let's write this down, a plus a, which is 2a, or a plus b. So the key here is one of these operands could be a, could be b. The other operand's always a. And so we can fill in that a operand, because we know it's not going to change, but this is going to change based on some other issue. So we have a mux sitting there, and it's either going to add a or b, and so we can put that in there. So now we've got it set up such that it can add a or b. What it's going to add is based on something else. So what we're going to see here is we're going to look at this thing, and we're going to compare a and b, which calls out for a comparator, because when they're equal, we need to do one thing. When they're not equal, we need to do another thing. So somewhere in here is a comparator. And what we need is just an EQ output, and that is going to control whether it chooses A or B. And so it's going to be comparing these two values, A and B. These are both 8-bit values. Looking good here. I got a couple more things to do. Here's my result, which is 8 bits, and I have a carryout. And the carryout is technically the 9th bit, so I'm going to use my little appending notation here. And this is going to be 9 bits for the output, which is my result. And last thing I need to do here is get these numbers in this muck. And as usual, I'm just going to guess. Essentially, that means when a and b are equal, it does a plus a. Is that right? And that's wrong. So when they're equal, I want to do a plus b. So these are wrong. Go ahead and erase those. And like I said, I always take a guess on these. You might want to put some thought into it beforehand rather than after. That's your own style on these things. I think essentially this is an issue of how this circuit is controlled. We have a decision being made there, and it's controlled by this signal right here, which is an internal signal. So this circuit is internally controlled. Now we are done.